Alright, so this is going to be another video of this little battery pack that I made with lithium-ion batteries. Uh, as you can see, it's about 15 volts right now, but fully charged it's about 16.4, 16.8. And right now I have it hooked into my Schumacher 410 watt inverter with just a little connector here, and I have my voltmeter plugged into it. I'm planning on making a much larger battery pack. I'm going to run all the high energy, or I should say high efficiency lights in the house off of it eventually. So this is very early stages here. Right now I have 2 rows, each have 4 18650 batteries in it, and each one's wired in series, and then out here I just have it tied in parallel. So right now I have it hooked into a kilowatt, and I have a very energy efficient light. It's a LED. It's a 40 watt replacement, and it uses only 4.8 watts, so we're going to see how true that really is and just how much power this draws. So let's go ahead and turn it on here and see. There's the light, it just came on. I'll show you again here. I'll turn this off and turn it on. Now the fans didn't even kick on the inverter, so that's good. So I'm getting about 115 volts out of that, and it dropped my battery down to about 14.86. So I'm okay with that. Let's check the amps, see how many amps it draws. Looks like it's about 0.06, 0.07. So that's actually really low. Let's check the watts. Okay, 4.5 watts. So that's actually a lot. That's a little bit lower than actually what the box says. So that's actually really good. And you know, if I make a larger battery pack, I could run these lights all day long. And it's only 14.84. So let's test out something else here, because it seems to be doing pretty good. Let's put another high efficiency bulb in. So they say this is sorry for my camera. This is a 26 watt, 390 milliamps, 60 hertz. So let's try that. All right, so let's go ahead and flip this on and see what happens here. And you can see my battery floated back up to 14.98. So that's good. So that time you can hear the fan kick on now. The light's on. It's putting out about 118 volts, using about 0.29 amps. So that's about right, 300 milliamps. Too many watts. Amps 0.3, so they have 300 milliamps. Sorry for my camera. I'm going to be getting a better one here. The watts is about 16, 17 watts. That's actually better than what the bulb is actually rated at. It says 26 watts, and I'm getting about 60 hertz, so it's pretty good. On my battery there at 14.35, that's pretty good. You can hear that in the background, the fan. Let's turn this off. Let's try another bulb. Let's see what this one is. This one is, get the camera to work here. Looks like 23 watts. Yeah, 23 watts. Again, 380 milliamps, it says right there. Wow, this camera sucks. Alright, let's try this one. Now these bulbs, you know, these are probably a couple years old already, but they were probably $7 to $10 a piece. So let's see what happens. That one came on. 14.44. 118 volts. So many amps. It's about 330 milliamps. That's about right. Watts 18.7, 19. So this one's a little bit truer as to what it says on the light. Alright. As you can see, that pulls the battery down a little bit more, but it should go right back up here. Yep, there it goes. Now I want to show you what happens if you put how unenergy efficient regular light bulbs are. I mean, as opposed to these older ones. Hang on one second. Alright. Sorry for the really crappy video. I'll be getting a stand and everything else, but this is a 72 watt bulb, if it works. 72 watts. $120 volts. So let's put this one in. Let's see what happens. I have a feeling that's going to suck the battery dry. Oh yeah, there it goes down. 13.8. We got 117 volts. It's pulling a half an amp, 0.6 many watts. Actually, it's pretty close. It's pulling 68. As it warms up, it'll go up here a little bit. So you can just see how big of a difference these older bulbs are as opposed to the newer bulbs. I mean, it's just insane. Could you imagine leaving a couple of these on just all day long? You're killing your energy bill. And this is, like I said, this is only a 72 watt, as opposed to this, 40 watt replacement uses 4.8 watts, and you could run these all day long. Now, granted, this bulb here is, it's a $13 bulb, but you replace all your bulbs, it's going to cost some money. But the fan didn't even come on with that. 0.06 amps is all that is drawing, and 4.5 watts. I mean, that's impressive. So I'm going to build a larger battery pack here, and actually try and run all the lights in the house off of it. So stay tuned, and I'll do some battery builds here, and you can just follow along. Thanks for watching.